Hi, I'm Ellen. I work in IP Networks Marketing, and today I'm here with my colleague Diego, who's a solution engineer here at Nokia. And Diego's going to give us a demo today on intent-based multi-domain networking. So Diego, could you give us some background? Who would need this, and tell me a little bit about their situation?
Well, what we are trying to do with intent-based multi-domain networking is to provide CSPs and network operators with the tools to provide differentiated services with stringent SLAs and low delay requirements that are both applicable to enterprise services as well as 4G and 5G oriented services.
Great. So let's look at the demo. Could you
All
show
right,
us?
of course.
Awesome.
Let's go. A few key terms and building blocks we need to understand before we start with this demo. One is multi-domain network, in this case, a group of interconnected networks. Then intent, which is basically a networking objective or an optimization objective. In this case, we are going to be looking at paths optimized on lowest delay end-to-end. Then color, which is a particular attribute carried or signaled in service routes, which in this case signals intent. Okay, and then we have, of course, the intent-aware path, which is basically the combination of endpoint plus color. All right, and then we have a few building blocks. One is the intent-aware transport, which in our case is going to be realized by segment routing TLSPs or segment routing LSPs or SRv6 tunnels. Okay, then we have the end-to-end overlay or service overlay, which in this case is going to be a layer 3 VPN service, but it can be a classic layer 3 VPN service or EVPN-based services too. And finally, the PCE control, an important part in cases where we are going to be using segment routing TE and along with on-demand SRTL space. So a few things, how to create intent-aware paths. So in this case, basically an application signals or signals that it needs the path with the lowest delay possible. Then the lowest delay possibly signal as an intent and is get assigned a color green, for example, as we have here in the slides. And then BGP service routes that are associated to these services are marked with a color community that carries a numerical value that represents color green. And then, of course, these BGP routes or BGP transport routes also in the cases where we use BGP-LU, as we will see in a moment, they are also signaled with an intent and a color, okay? That is used to resolve the next hops of those routes. And then finally, we have MPLS, RSVP TLSPs or IGP segment routing LSPs that are also marked with a specific color that signals the intent, okay? So then we have the how to apply intent to flows. In this case, it can be done in two ways. One of those two ways is using CVR or using PVR, which is basically local policy configured in a specific ingress node, or we can also have sort of a network coordinated policy in which ingress PEs are going to tag or signal the intent in service routes, as we mentioned before, and those routes and with a color, and the color is going to be used to map those flows to the specific intents or the specific LSPs used in this demo, right? Well, you know, a few definitions of a flow can be, you know, these policies can be applied per service. They can be applied for BGP next hop or route type, right? And then we have intent-aware route auto-binds to BGP-LU tunnels or to flex-algo channels to a colored segment routing TE or segment routing policy. Okay, so now let's jump into a live demo. So first of all, this is the final picture in our demo. This is where we want to be at the end, right? So as you can see here, we have a multi-domain network. Let me just choose my laser pointer here. So we have a multi-domain network. As you can see, the blue domain is the SRv6 network, and the pink domain is the SRT or the SR-MPLS network. And as you can see, we have multiple domains, which in this case are multiple IGP instances to the left and the right, okay? And of course, we have services on top of this network. So this is, and also as you can see, in each network we have flex-algo 128, which in this case is its optimization objective is lowest latency end-to-end, okay? So now, the first portion of the demo, the first section of the demo, we will show how we have a flex-algo enabled segment routing OSPF instance, or it can be segment routing ISIS if you would prefer. So in this case, each node is assigned a node seed that belongs to that specific flex-algo, okay? And of course, then packets are going to be routed on top of these packets. Now, going to the CLI here, I will show you, for example, a piece of information, which is the topology, the flex-algo topology that we have. So in this case, we can see here that we have all the prefix seeds. For example, in our SR-MPLS network, we have all the prefix seeds associated to algo 128, as you can see here within a specific IGP instance. We also have the channel table, where in the channel table we can see all the segment routing OSPF LSPs that were created, and you can see they have different metrics, where you see a metric of 1000 and above. Those are delay optimized SRISIS LSPs, okay? And for multi-domain, for inter-domain segment routing TE or segment routing tranche. So for inter-domain traffic, since we are going to be using BGP-LU LSPs, so in this case, you can see that we have a series of routes that are tagged with a specific colo community, and this colo community plus the endpoint is used to map this traffic to a flex-algo network signaled via segment routing ISIS, okay? Excellent. So going back to the slides, so as you can see, I show you there that we had our flex-algo enabled OSPF instance. We also have BGP-LU tunnels, as I was mentioning before. So BGP tunnels or BGP-LU tunnels with segment routing are used for inter-domain connectivity in this case. So as I was showing before, we had routes being propagated with the specific attributes that we need in order to build these inter-domain LSPs. So one of the other options that we have in order to realize an intent-aware multi-domain network is to use on-demand SRTE tunnels that are computed by a PCE, in this case, our own NSP PCE. So as you can see in this image, we have the same multi-domain SR OSPF network, and we have VPN routes being advertised between PEs, as you can see to the left and to the right. And upon receiving these routes, these two ingress nodes are going to create those LSPs and send to the PCE a path computation request. And now I will show you in our PCE GUI, in our NSP PCE GUI, that we have a series of LSPs that have been created on demand based on the PCE request that was sent previously by the ingress nodes or PCC. So in this case, the PCE has computed a path for these specific LSPs, and they are signaled using PCEP back to the PCC, okay? If we take a look at some of the attributes of these LSPs, you can see that they are actually up, and that they are transporting traffic, as you can see on this column, and also you can see that these LSPs are being optimized on end-to-end delay. So you can see here that the end-to-end delay of this LSP is this value that you can see here in this column. Now, if we take let's say a deeper look at those LSPs, so we can see here on the map, for example, where those LSPs are placed in the network and all the resources they are using. So this is an excellent tool to provide or to realize an intent-aware multi-domain network, okay? Going back to the slides, so the next case is segment routing V6, in this case using flex-algo along with compressed seeds in order to create an end-to-end multi-domain network. So I just wanted to show you in our CLI, for example, in this case we have those microsegment locators those compressed seeds and compressed locators that belong to algo 128. In this case, we are in DUT 13, which is, let's say, a dual stack DUT or ingress node that supports both segment routing MPLS and segment routing V6. So you can see here those microsegment locators associated to algo 128. Then you can also see a bit of topology information for this specific flex-algo. So you can see that all of the nodes within that specific domain, remember that the flex-algo is enabled on a per domain basis, are present here in the database in the node. So you can see that some nodes are reachable through a group of interface or an interface or a next hop, and they have a specific metric to reach that next hop, right? And something I forgot to mention before is that in this list of microsegment locators that we have here in our ISIS database, we have locators that are local to the device that we are sitting in right here. And we also have some or a few locators, for example, these locators here and these locators down here, which are summary locators. These routes basically are routes that are summarizing locator prefixes that belong to a different region of the network, okay? Which is a very important aspect of an SRv6 multi-domain intent-aware transport network. And finally, I wanted to show you the channel table in this specific node, where you can see, for example, that we have installed those segment routing SRv6 ISIS channels for them to be used by services, okay? So, finally, a series of services that are using these SR-MPLS routes, SRTE routes, and SRv6 routes. So first of all, as you can see here, the layer 3 VPN services are going to be advertised with a series of attributes that are going to be used by the ingress nodes in order to map those services to either an SR-MPLS path using or signaled or computed using flex-algo or signaled and established using BGP-LU, or even signaled using or unestablished using segment routing TE, PSEP and PSEP, and along with our NSP PCE, okay? And finally, before we jump into the CLI for the last time today, we will show you also an SRv6 service in this case. As you can see right here on the right side of this slide, you will see that DUT 16 or DUT 15 in this case is advertising a specific VPN route with SRv6 related information that is going to be used by the ingress node right here to the right, to the left, in order to be able to steer that traffic onto this specific topology computed by flexible algorithms, okay? So let me just jump to the CLI now. So first of all, what I wanted to show you here is that these services right now, we have two services, VPN 100 and VPN 100.1, and those are using segment routing ISIS, segment routing with BGP level unicast, and SRT. So as you can see here in these common outputs for service 100, so all the roads or all the tunnels to reach the next hops are signaled using or are resolved using segment routing ISI, segment routing OSPF or BGP. And in the case of service 101, we are using also segment routing TE. So as you can see the difference between one and the other. And another nice thing I wanted to show you is the following in NSP. So NSP can also monitor traffic utilization on a per layer 3 interface basis. So as you can see here, we have traffic utilization on interfaces that are pointing or are connected to the SR-MPLS network. So you see here the utilization is around 20 megs, and then the utilization in the other interface connected to the IPv6 network for SRv6, the utilization at this point is 0, okay? And you can see here in multiple interfaces in different nodes. So for example, in this node up here, so we see 0 utilization on the SRv6 interface and around 30 megs of utilization on the SR-MPLS interface. Now, if we go back to the node, okay, so what we are going to do now is just to migrate from SR-MPLS and SRTE and BGP-LU to SRv6. So in this case, we enter this command, okay? And with this, we see how the traffic is going to start using SRv6 tunnels to encapsulate this or services, excuse me, are going to use or will start using SRv6 to encapsulate these packets. So as you can see, service 100, it was using SRSPF before, and it was using also BGPLU, is now using SRv6, as you can see here, and the same applies for service 101. It was using segment routing TE, but now is using SRv6, as you can see here in all of these routing entries or routing table entries. Now, if we switch back to NSP, so in NSP, we will see a shift in the traffic patterns in this case. So you see up here, this interface had a 0% utilization before the change, and now the traffic or the bandwidth utilization went up to 25 megs, more or less, okay? And as you can see, the traffic on the SR-MPLS interface was reduced from 20 or around 30 megs to 0 megs, as you can see here. And you can observe this pattern in all the interfaces from ingress nodes connected either to the SR-MPLS network or to the SRv6 network. So I think this is it. Well, the idea was to show you how with SROS you can have a multi-domain intent-aware SRv6 network, SRv6 and SR-MPLS network, and how you can seamlessly migrate from either a legacy technology like LDP, RSVP to SR-MPLS, or finally to segment routing v6 with just a single command.
That was really interesting. So to recap, can you just cover a couple of the advantages network operators can see?
Of course. So with intent-based multi-domain networking, operators will have the possibility of providing differentiated services that apply to both enterprise customers as well as 4G and 5G applications, thanks to the feature set that we have both in segment routing and segment routing TE, or thanks, in fact, to segment routing TE, and flexible algorithms.
And to wrap it up, what would you want our audience to remember?
Oh, that's a great question. So we want our audience to know and to remember that with SROS and its extensive segment routing toolkit, you will have the right tools for the right job. It doesn't matter if you have a legacy IPv4 MPLS network, or if you are looking into having a pure IPv6 network with segment routing v6.
Great, thanks so much.
Thank you.